Alright, so this is our introduction to Chapter 6, which is focusing on calculus. So this is a very exciting chapter because it's your first look at a very new topic. So our learning targets for this lesson are to 1. Understand the derivative is the gradient of the tangent line at a given point, and 2. Use differentiation to find the gradient at a given x value. The gradient of a tangent line, that is, at a given x value. So you need to have these down in your notes. Remember that at any point you can pause this video and write things down if I'm talking too quickly. Or if you need to hear something again, you can rewind it and as many times as you want. That's the benefit of screencasts. Alright, so let's move forward. So I thought you probably wanted to look at what calculus is and why you should study it, because you know, in your mathematical future, you're going to be spending a lot of time doing calculus, and it actually is a very applicable topic. So this is what wisegeek.com says. It says, the branch of mathematics called calculus originates from describing the basic physical properties of our universe, such as the motion of planets and molecules. Calculus approaches the paths of objects in motion as curves or functions, and then determines the value of these functions to calculate the rate of change, area, or volume. In the 18th century, Sir Isaac Newton and Gottfried Leibniz simultaneously yet separately described calculus to help solve problems in physics. The two divisions of calculus, differential and integral, can solve problems like the velocity of a moving object at a certain moment in time, or the surface area of a complex object like a lampshade. So we're actually going to be focusing on the differential part of calculus in the next couple of chapters, and that's going to help us look at the velocity of moving objects at certain moments in time. Okay, and just as a side note, for those of you who love to read, there's a great book called The Calculus Wars that talks about Sir Isaac Newton and Gottfried Leibniz's conflict over calculus, because they had different notations, they had different methods of arriving at the same result, yet they battled it out. It was pretty intense, so that's a pretty good book if you are looking for some fun math reading. Alright, moving forward. So the key concept for this lesson is that this is what you need to kind of keep at the back of your mind, that any reasonably smooth curve has a gradient or slope at a given point. So that means if I were to place a point on a curve anywhere and construct a tangent line, that line would have a slope. Alright, so let's kind of remind ourselves about what a tangent line is. So both of these lines are tangents. This is the dark pink one. You can see that it touches our curve. In this case, it's a circle at a single point. And this light pink, or peach line, does the same thing, just at another point. So from geometry or prior, you hopefully remember that when we say tangent, we mean that it's a line or a plane, and we're going to be talking only about lines today, that touch a curve or a curved surface at a single point, one point only. Alright, so what I want you to notice is, even though these are both tangents, if we were to think about them in terms of slope, their slopes would be different. This line, the dark pink one, would have a positive slope, and this peach line would actually have a negative slope. Even though they're both tangent, they represent, their slopes are different. So let's kind of look at this video and see how this looks along a curve. So this is an animation to show you. So our line, okay, let's just watch it once, then I'll explain what's happening. So the black point you see is the point of tangency, and the line segment is white. So here we go, we're going to follow this. So as it's going upward, our slope is positive. It hits the top, so we have a slope of 0, then downwards, negative slope, positive, slope of 0, downward slope, slope of 0, and positive slope. So you can see that all along this curve, the slope is continually changing, and the only way we could accurately look at the slope is to look at it at a given point. So that's why we keep saying that we are looking at slope, or the derivative, at a given point. So let's talk about what these words mean, the derivative and the method used to find it, differentiation. So when we say differentiation, it's the method we use to calculate the gradient or slope or the change in y with respect to the change of x. This phrase here should hopefully be very familiar to you because this is how we talk about slope a lot. So differentiation just helps us find slope. It's a method that we find slope using the tangent line. Okay, using the tangent, yes, line, what I just said. The derivative proper is the rate of change measured at a given point. So when I say the derivative, I'm really saying the slope, okay, at some point. Okay, so I want you to think about this, and we're going to actually explore this in class together using Geometer's Sketchpad on Monday. But why is the derivative the gradient of the tangent line at a given point, and how and why does that work? So from your studies of math in the past, you usually have to have 2 points to find the slope of a line, and now I'm telling you, you can use differentiation and the tangent point to find the slope. Why does that work? So kind of keep that in the back of your mind and be thinking about that so we can discuss it on Monday. So let's get down to differentiating. This is the skill of this section. So basically, how to differentiate. If we have f of x equal to x to the n power, okay, so f of x being a function, n has to be a real number, so non-imaginary. Then when we differentiate this little part here, we could read as f prime of x. We could read it, the British say f dashed of x. I don't usually say that, I usually say f prime of x. Or we could even read this as the derivative of f of x. Okay? That equals nx to the quantity n minus 1 power. So what you should notice is the exponent in our original function gets kicked out front. So we basically multiply our function by n. Okay, so that's what happens here. Then we take our exponent, which is n, so it's what we started with, and we're taking away 1. So our exponent is 1 less than what we started with. Okay, so make sure you have this clearly down in your notes. I would put a huge box around it because we're going to be using this, well, you're going to be using this forever and ever and ever. So have it jotted down in your notes. All right, so let's go ahead and practice differentiating each function. So we're going to start with a of x. So our first thing is we need to write that we're finding the derivative. So we're going to say a prime of x or a dashed of x, like the British. Okay, so the first thing is we're going to deal with our exponent. So the 2 gets kicked out front. So we're going to say 2 times, okay, what's already here, 10, x to the, now we take our exponent and we take away 1. Okay, so we end up with 2 times 10 is 20, x to the power of 2 minus 1, which is 1. So a prime of x equals 20x. Okay? So we use differentiation to find this. Now we could find the slope at any point on this curve, 10x squared, by plugging in an x value here. Okay, and we'll get to that on the after we practice a few more differentiations. Okay, so let's do b of x now. So I'm going to say that I'm finding the derivative of b of x, which is b prime of x. Okay, now you'll notice this one has 2 terms. So we have term 1 and term 2, and we're just going to basically do these separately. So we're going to take our 2 and we're going to kick it out front. So we say 2 times what's already there, which is negative 4x. And then our exponent becomes less 1. So it's 2 minus 1. Alright? So now let's do the second term. So our exponent here, even though it's not written, is 1. So we would say minus 1 times what's already there, which is negative 3x. Okay. And now our exponent is 1, and we take away 1. Okay. So now let's go ahead and simplify it. Oops, and this should be positive. Getting sloppy there, just 1 negative. I wrote up front. Okay, so 2 times negative 4 is negative 8. X to the power of 2 minus 1, which is 1. So we'll just say negative 8x. Minus 1 times 3 is 3. And then x to the power of 1 minus 1. Well, 1 minus 1 is 0. Anything to the 0 power is 1. So this ends up being negative 3 times 1, which is negative 3. Alright, so here is our derivative, b of x.